Audio, like I said, 8.1 polynomial functions. Remember, polynomials just means an expression with one or more terms in it, okay? So some definitions that'll help you in this section. When I talk about the degree of a polynomial, I'm talking about the highest exponent. So the degree is equal to the highest exponent of the polynomial. Okay, so a lot of times they're going to be in order, but y'all sometimes in this section they're out of order. So you're just looking for the highest exponent, okay? All right, we got what we call the leading term. So the leading term is the term of the polynomial that contains the highest degree. So it's the term of the polynomial that contains the highest exponent. So the leading term contains the highest exponent, which means the degree is found by using the exponent of the highest of the leading term, okay? All right, then you've got what we call a lead coefficient. So a coefficient is just a number. So when I talk about the lead coefficient, I'm talking about the number in front of the leading term. All right, so the leading term contains the lead coefficient. It contains the degree of the polynomial, okay? Alrighty, y'all. So just for an example, um, given, say my polynomial is a 7x to the fifth minus 4x squared plus 3x minus 2. So given this polynomial, I want to know the leading term, the lead coefficient, and the degree. All right, y'all. So on this one, the leading term is the term that contains the highest exponent. So this whole thing, the 7x to the fifth, is what we would consider the leading term. So the terms are separated by subtraction and adding, okay? So this one has 1, 2, 3. This one would have 4 terms. But the leading term has the highest exponent. So the lead coefficient we said was the number in front of the leading term. So since 7x to the fifth is the leading term, the lead coefficient would be 7. And then the degree we said was equal to the highest exponent. So since my highest exponent is a 5, the degree of this polynomial would be a 5. Okay, so this is just to get you familiar when I'm looking at polynomials, how to find these things, okay? All right, so what we really want to look at in this section when we get started is what the graphs look like. And we're going to be looking at the end behavior of the graphs. So y'all, I'm just going to show you something real quick on this calculator. I'm going to graph an x squared. So something like 2x squared. So this 2x squared, I want you to see what happens on the graph. So if you notice, both ends go up, makes like a parabola. And y'all, we've been doing the parabolas for a while now. But what I want to do, I'm going to change that exponent of a 2 into a 4. And I want you to look at this. When I graph it, it looks the same. It looks like a parabola. The only difference in the middle, there might be a few more turns, and you can't tell on this. But y'all, the even exponents like 2's and 4's all make parabola shapes. Now, what if this was a cube? So let's cube it and look at that graph. Remember, the cubes make that little squiggly line. So there you go, your squiggly line. But what I want to do now is change that 3 to a 5. And look at that graph. So it still does the same squiggly type graph. So we can make a chart and predict what these graphs are going to look like as they head out towards infinity on them x directions, okay? So this graph that we're going to make, we call this this chart, we call this an end behavior chart. So this end behavior chart, it looks at the degree of the polynomial, and we're going to look at the lead coefficient. So the degree can be even or odd. The lead coefficient can be positive or it could be negative. Based on the degree and the lead coefficient, this chart will show us how we can predict what the graphs will look like in the big picture, okay? Well, we just looked at a couple even degrees. I did an x squared and a x to the fourth, and they both had a positive 2 in the front. So we've seen that when it was an even exponent, both ends of the graph went uphill. Now they leave this blank in the middle because if that's an x squared, it don't make but one turn. If it was an x4, it would make a few turns and then go up. X6, a couple more turns, but eventually they all look the same, okay? Now, when that was an odd degree, we seen that the graphs went uphill, left to right. So when I did the x cubed and the x5, they sort of went uphill, left to right. Those all had an even lead, a positive lead coefficient. So positive with an even degree, positive with an odd degree. So what happens when they're negative lead coefficients? Well, y'all, what that's going to do, if I go to my calculator, and let me make that a negative 2x squared. All right, so negative 2x squared, when you graph it, it flips it over. So remember the negatives in front of the function, reflect them over the x-axis. So a negative with an even degree Both ends will go downhill. And the same thing with the odd. The odd was going uphill with a positive degree, a positive lead coefficient. So if it's got a negative lead coefficient, this thing is going to head downhill left and right. So even degree, positive lead coefficient, both uphill. Even degree, negative lead coefficient, both downhill. Odd degree, positive, uphill. Odd degree, negative, downhill. Okay? So your positives go to the first row, your negative lead coefficients, second row. Even degrees, first column, odd degrees, second column. So y'all, we're going to look at some problems and see what y'all think on these. So let's go to Math Lab. All right, y'all, so for this first one, A, B, C, or D, f of x is a negative square root of 2, x to the third, plus 4x squared, minus 2x, plus 4. First, we want to know if the degree is even or odd. Then we want to know if the lead coefficient is positive or negative. So y'all, as we're looking through this one, the highest exponent is a 3. So that means that the negative square root of 2, x to the third, is my leading term. It's got an odd degree of 3, and it's got a negative lead coefficient. So y'all, when it was odd and negative, would we pick A, B, C, or D? So B, right? It's odd degree and it's negative, so that graph should go downhill left to right. So y'all, you would come in here, put a B in the blank, and you're going to check your answer. All right, so let's try that on this second one. P of x equals negative pi x to the 6 plus x to the 5th minus x to the 4th minus x plus 6. So our highest degree on this one, our highest exponent is a 6. So that means that negative pi x to the 6th is my leading term. So y'all, when you got a negative lead coefficient and an even degree, A, B, C, or D. All right, y'all, so that is definitely a good job. That is definitely C. Both ends will go down. And y'all, that's the trick on these first four is just using your chart there. How about this one? Negative 3.8 x to the 4th plus x to the 6th plus 0.5 x to the 7th. So y'all, let me just ask y'all this. What is the degree of this polynomial? All right, y'all. So the degree is 7. The highest exponent is a 7. So that means that the 0.5 x to the 7th is my leading term. The degree is an odd 7, and the 0.5 is positive. So you got an odd degree, positive. So being you got a D on there, good job. That's going to go uphill, left to right. So it looks like I got Ben right off the bat because of that order, but y'all watch out. You're looking for the highest exponent on that thing, okay? One more of those and then we'll move to something different. So, A, B, C, or D? See what y'all think. All right, so y'all got an A there, Ben. Let's see. Yeah, because the highest exponent is a 4. That's even. So 1/10 x to the fourth is your leading term. They're just out of order. So positive and even, both will go up. So definitely that is A. Hey, y'all, so that's how they start out on that. Then we get into stuff like, so let me write this one down. So they want us to use substitution and determine if 4 is a zero of the following. They got f of x equals x cubed minus 11x squared plus 16x plus 48. So they want to know if that 4 is a zero of the following. Well, here's a little thing that I'll write about this. If a number is a zero of a polynomial, then the result of plugging that number into the polynomial will result in an answer of, well, guess what? If it's a zero and I plug my number into that polynomial, then I better get an answer of zero. That's the property of it to be a zero. When I plug it in, it's got to equal zero. So what I got to figure out, they want me to see is 4 or 0 of this. So I'm going to evaluate f of 4. I'm going to put a 4 in for all the x's. So I get 4 cubed minus 11 times 4 squared plus 16 times 4 plus 48. We need to go through and see what all that equals. And if I get a 0, then the answer would be yes. If I get any other number, the answer will be no. So y'all want to do the exponents first. So 4 times 4 times 4 is 64 minus 11 times 4 squared. 4 times 4 is 16. And I'm just bringing everything else down. I just wanted to work my exponents first. So I did that exponent and that exponent. Now I'm going to do the multiplying. So I got 64 minus 11 times 16, which is 176, plus 16 times 4 is 64, and then plus 48. All right, y'all, so let's just add that and see what we get. 64 minus 176 plus 64 plus 48 equals, we ought to add that and see what we get. All right, good job. The same thing I got was a big 0. Since we got a 0 for the answer when we plug that in, your answer to this one would be yes. 4 is a 0. All right, y'all, so new words. We know what a 0 is, but what about this one? Multiplicity. So y'all, here's what a multiplicity is. The multiplicity is the number of times that a zero occurs. If the zero is in parentheses, then the multiplicity is equal to the exponent following the parentheses. All right, so let me show you what I'm talking about. If I had something like x plus 3 to the fifth, I would find the zero by setting the parentheses equal to zero, and then the multiplicity would be the 5, because that's how many times you would write this factor. X plus 3 times x plus 3 times x plus 3. That's what that 5's telling us. So that means this zero is occurring 5 times. So to find the zero, set x plus 3 equal to 0. And y'all, you would solve that by subtracting 3. So the 0 would be negative 3. That's what you add to positive 3 to make that 0. So the 0 equals negative 3. Multiplicity is that exponent of 5. Okay? Now, so that was when they're in parentheses, okay? If the 0 is a single term, then the multiplicity is equal to its exponent. And y'all, here's the cool thing about these. So say I had 3x to the fourth. We don't even care about that 3. Anytime it's a single factor like this is, you would set 3x equal to 0. And then you would just solve this by dividing by 3. And you get x equals 0. If it's a single factor like that, it's always going to be a 0 of 0. Single factors are always 0. So the 0 would be 0. And that's the only time your zeros will equal 0 is when it's a single factor, okay? And then this one would have a multiplicity is its exponent of 4. So this would be like writing 3 times x times x times x times x. And it don't even matter what number's in front of a single term like this. That number's getting divided out, and 0 divided by anything is still going to be 0. So that could be a positive number, negative number. It don't matter. Any of these single factors will always have a 0 of 0, okay? But you also knowing that, let's see what they're hitting us with. So they want us to find the zeros and multiplicities. Y'all, so on number 6, they're giving me f of x equals x squared minus 25 in parentheses to the fourth power. So since this is the x squared in parentheses, that means I'm looking for two zeros. But they'll have the same multiplicity because there's a 4 outside those parentheses, okay? So you're going to set your factor equal to 0. We're going to solve this for the x. So since this is an x squared and a number, when we do the quadratic stuff, on these ones I added 25 and I did the square root. So y'all going to do the same thing here. Add 25. I'm going to do the square root once I bring that 25 down. Now remember, I got to get two answers. So I'm going to do the square root of x squared equals square root of 25. Square root of x squared is x. But y'all remember, since I'm taking the square root of a number, that could be a positive or negative 5. 5 times 5 is 25. Negative 5 times negative 5 is 25. So when you're doing square roots, you got to take into account the plus and minus answers, okay? So for this one, my zeros, or you can put plus or minus 5. You can do it like this. Or you could do 5 comma negative 5. It'll take them either way. And multiplicities of, well, y'all, there's my multiplicity, that exponent on the outside of the parentheses, which is a 4. Because that 4 means this would be an x squared minus 25 times x squared minus 25 times x squared minus 25 times x squared minus 25. So you would have 4 sets of parentheses technically if you was to expand it out, okay? They don't care about all doing all that. They just want to know what your zeros are and their multiplicity. All right, y'all, this one has f of x equals x cubed times x minus 5 squared times x plus 9. Now, when we do this one, the answer blank says the smallest zero is blank with multiplicity blank. Then it says the middle zero is blank with multiplicity blank. The largest zero is blank with multiplicity blank. So that's how we're going to answer this one. They gave us blanks and we got to fill stuff in. So I got 3 factors. So on the first one, I'm going to set x equal to 0. Well, y'all, you can't do nothing else on that one. We said single factors would always equal 0. For the second one, you got x minus 5. You'll set that equal to 0. To solve it, I'm just going to add 5 to both sides. And I get x is a positive 5. For the third one, I'll set x plus 9 equal to 0. So on that one, I'll subtract 9. And again, x is a -9. So my three zeros are 0, 5, and -9. So as they say, what is the smallest zero? Well, y'all out of them three zeros, which one's the smallest? Oh, there you go, Olivia. It's a -9. So the smallest zero is -9. So let me ask y'all this. There's not a number outside those parentheses. So technically, what number would be outside those parentheses? Remember, if anything don't have an exponent by it, it's automatically a 1. So since these parentheses didn't have an exponent, it's a 1. So that means the 0 of -9 has a multiplicity of 1. All right, so you got 0 and 5. Which one's the middle zero? All right, 0. Because you're looking at a number line, -9 is the smallest, then you got 0, then you got 5, right, on the number line. So that means 0 is the middle one. What's the multiplicity of the 0 of 0? So the 0 of 0 came from this one. What do you got? 3. Good job. Because that came from this factor. So the largest 0 is going to be obviously the 5. And it had a multiplicity of, so where we got that from right there, and it has multiplicity of 2. And so that when they're just sort of making you put in the answers how they want them, okay? All right, y'all, we got one more of those, and then it sort of switches gears. All right, y'all, so the same thing. Let's see what they're giving me. F of x equals -6 times x minus 1 to the fourth times x plus 5 to the third times x squared. Now I'm only worried about variables, the x minus 1, the x plus 5, and then the x squared. This -6 does not have a variable with it, so we can technically cross out that factor. That is a constant number, so we do not use it to find zeros because there's nothing to do to a -6 to make it a 0, okay? You're only worried about factors with variables. So my factors will be x minus 1. I'll set that equal to 0. X plus 5. I'll set that equal to 0. And then on the x squared, I'll set that x equal to 0. Once again, the single variable is always going to equal 0, okay? So these two you actually got to figure out. So y'all, I'm going to add 1 to the first one. We get x is a +1. On the second one, we would subtract 5. We get x is a -5. So I got my three zeros, 1, -5, and 0. Remember, we are not worried about numbers without variables, okay? All right, so here's how these answers will go. The 0, 1 has multiplicity blank. Blank is a 0 of multiplicity 3. The remaining 0 is blank. It has multiplicity blank. All right, y'all, so let's answer this question. The 0 of 1 has a multiplicity of what? Well, here's your 0 of 1. You got it from this factor, and the exponent for this factor is 4. Good job, Olivia. Good job. So that was a 4. Now what goes here? Blank is a 0 of multiplicity 3. So what would go in that blank? -5. Good job, because that 0 we found right there. So y'all, that means the remaining 0 is blank, and it has a multiplicity of blank. And that's good job, right? 0 was the remaining one, and it had a multiplicity, good job, of a 2. All right, y'all. So those ones were already factored. Let's do some of these that are not already factored. We'll do some of these that we got to factor. So y'all, I'm going to show y'all a new way to factor. So this wants to find the zeros and their multiplicities. Alrighty. So when you hit number 9, they're going to give you something like this. F of x equals x cubed minus 7x squared minus x plus 7. So y'all, anytime you got 4 terms like this, we're going to factor this by grouping. So not sure if y'all are going to remember this, but I'll sort of write out what I'm doing as I go through it. So when you got 4 terms, we factor by grouping. So the first thing you want to do is group the first 2 terms together and the second 2 terms together. So group first 2 terms together. Group last 2 terms together. So I grouped my first 2 together, my last 2 together. Now, factor out the greatest common factor for each group. So I'm going to factor out the greatest common factor between these first 2 groups and then the second 2 groups. Now the thing about it is, on the second pair of terms, you at least got to factor out a 1, okay? All right, y'all, so let's see. The first 2 terms, greatest common factor is the greatest that they got in common. So it can't be a number because this one don't have a number other than a 1. So I'm looking at the variables. You got an x cubed and an x squared. The most that they have in common is an x squared. So you would factor out an x squared and then put what's left in parentheses. So if you had an x cubed, you factor out an x squared. That's going to leave you an x minus. If you had a 7x squared and factor out the x squared, you're left with a 7. Now, if you notice, x and 7 don't have nothing else in common. So that's the greatest common factor on the first two was an x squared. So now I do the last two. Now, check this out. The second greatest common factor must have the same sign as the third term. So remember, first term, second term, third term, fourth term. So since the third term is negative, that means that my second GCF will be negative. All right, so on this one, x and 7, they only have one factor in common. Y'all remember what I said it would be? So good job being it'll be a 1. So remember, you at least got to factor out a 1 on the second GCF, okay? So what happens if I factor out a negative 1? Negative divided by negative makes that a positive x. 7, factor out a negative 1, leaves you a negative 7. Now, y'all need to notice what you got to have at this point. At this point, these parentheses got to match up here, okay? So notice I got an x minus 7 in parentheses here, x minus 7 in parentheses here. So at this point, parentheses must match. All right, so now what you do, you got two big terms here. They both have in common x minus 7. So you're going to sort of factor out the x minus 7. So y'all let me ask you this. If I take out the x minus 7 here and the x minus 7 here, what's left for my parentheses is going to be the x squared minus the 1. So we're just sort of rewriting this, but the x minus 7 now serves as the greatest common factor for these two terms. All right, at this point, we're done factoring. Now, neither one of these parentheses have an exponent on the outside. So what exponent would I technically put on the outside of both them parentheses? So Jenna, what you got there? 1, that sounds good. A 1 would go here, and a 1 would go here. So that means the multiplicities of both of these is a 1. Now y'all look here. You see how that was an x to the third? That 3 means I need 3 zeros. Well, I'm going to get 1 here, and then the other 2 on this one. That's going to give me 3 altogether. So I'm going to set x minus 7 equal to 0. I'm going to set x squared minus 1 equal to 0. So y'all, this will give me one of them because I'm just going to add 7 and be done. So that gives me x is a positive 7. This one, I got an x squared in a number, so I'm going to add 1 and do my square roots. All right, so square root both sides. So that's going to give me x equals a plus or minus. Square root of 1 is 1. So the zeros are blank. Each has multiplicity blank. Well, here's my zeros. I had a 7. I had a 1 or a negative 1. Now you can do 7 and plus or minus 1. It'll take that also. And then each had a multiplicity of 1. So once you get it down to the parentheses like this, if there's no exponents, you got to put a 1 there, okay? And y'all, number 10 is just like that one, so you'll get to see me do another one of those, okay? They're sort of tricky doing these 4 terms, but we'll get y'all there. All right, y'all, so let me do number 10 and then we'll probably take a break. All right, so find the zeros and the multiplicities. So y'all on this one are giving me f of x equals 2x cubed minus x squared minus 98x plus 49. All right, so 4 terms again. So you're going to group your first 2 and your second 2. So on the first 2, let's factor out a greatest common factor. So it can't be a number because there's only a 1 in front of this one. So how many x's can we break out? Olivia, what you got? X squared? Sounds good. So let me ask you this. If you factored out an x squared, Olivia, what would you put in these parentheses? All right, so that's going to give me a 2x minus 1. Perfect. Because x squared divided by x squared is definitely a 1 on that one, okay? Now, knowing what has to be in these parentheses, the second GCF will be negative. And y'all, guess what? This one does have numbers. I got a 98 and a 49. The largest common factor between a 98 and a 49 is going to be the 49. And I know that because I need a 1 over here, and there's a 49 there. The only way to get a 1 in here is if that was a 49 divided by 49 at the end, okay? So let's see. 98x divided by 49, well, y'all, that negative divided by negative is going to leave you a positive 2x. And then a 49 divided by negative 49 makes that a negative 1. So knowing what you need here to match this, you can almost figure out what's got to come out based on what you need in here, okay? All right, so I said these parentheses match up, so they come out as a greatest common factor. And then everything that's left, the x squared minus 49, will become my second factor. Now remember, that's an x to the third again, so I need 3 zeros. Well, this will give me 1, and that'll give me the other 2. Now, you don't see multiplicities on these again, so both of these parentheses will have a 1 for their multiplicity. All right, y'all, so I'm going to set 2x minus 1 equal to 0, and then the x squared minus 49 equal to 0. So solve this one and we'll solve that one. So y'all here, we would add 1. So you get 2x equals 1, and then divide both them by 2. So that cancels, and I get x is a 1/2. Now on this one, x squared in a number, I'm going to add 49 and do the square roots. So that x squared will come down, that cancels. That's going to be 49. All right, square root both sides. So square root of x squared is x, and this will equal a plus or minus square root of 49, which is 7. So once again, zeros are, and each has multiplicity blank. So for that one, I would have what, a 1/2, 7, -7, and then each one of them we said had a multiplicity of 1. Oh, y'all, so that is factoring your 4-term polynomials. Make 2 groups, factor out them GCFs, and then once you got that, set them in 2 sets of parentheses. And at that point, just start finding your zeros, okay? All right, y'all, so I'm probably going to do a little break real quick. So let me stop that share, and then we'll pause. All right, y'all, so the last 2 questions are like true-false questions, and it deals with the zeros, okay? So if a zero has an even degree or multiplicity, then it's tangent to the x-axis. If a zero has a odd multiplicity, then that means that it crosses right through the x-axis. Okay? So y'all, let me show you an example on the calculator. So I'm going to do a 0 here, x minus 4, and that'll be to the third. And then I'll do a x plus 2, and I'll make that exponent of 4. So I want you to see x minus 4. The 0 for that would be 4. If you set that equal to 0, you'd get a 4. And at 4, since that's an odd multiplicity, it's going to go right through the x-axis. Now the second one, x plus 2, that 0 is at -2. And since that's a even multiplicity, it's going to come down and touch the x-axis, and I want y'all to see that. So see how over here at -2, the graph came up, touches the x-axis, and then curves back down. But over here at +4, it goes right across the x-axis, okay? So we're going to answer questions based on this. If a 0 has an even multiplicity, then it's tangent to the x-axis. That means it just comes up and touches it and goes back down, okay? If a 0 has an odd multiplicity, then it crosses the x-axis. Okay, so we're going to answer 2 questions based on that right there. So let's go to Math Lab. All right, y'all, so let me go down. Those are last two. So number 11. All right, y'all, so here we go. It says if P of X equals X minus 9 to the 10th, X plus 4 to the 3rd, then the graph of the polynomial Y equals P of X crosses the X-axis at 9, 0. So you got to figure out which factor would give you a 0 and 9. And that'd be the first one, the X minus 9. It's got an even multiplicity. So since it's an even multiplicity, technically, it's just going to come down and be tangent to the x-axis. So that is false, saying it crosses. So we need to go to B or C. B, the statement is false because x minus 9 to the 10th is a factor of the given polynomial, and the exponent 10 is odd. Well, y'all, 10 is not an odd number, so it can't be B. So let's look at C. It says it's false because x minus 10 is a factor of the polynomial, and the exponent 10 is even. Thus, the graph is tangent. So you want C on that one. So look at the answers because they'll get the odd and even part mixed up, okay? So let's go to number 12, the last one. If P of X equals X minus 4 to the 7th, X plus 5 to the 8th, then the graph of the polynomial function Y equals P of X is tangent to the x-axis at negative 5, 0. So which of the factors would give me a negative 5? That's going to be the x plus 5. And 8 is an even multiplicity, so this will be tangent. So that one's true. So Ben, what do we got? D, it's true because x plus 5 to the 8th is a factor, and the exponent 8 is even, thus it's tangent to the x-axis. And that'd be perfect on that one, okay? So good job on that one. All right, y'all. So now we'll get into 8.2 here. I'm going to try and get MATLAB pulled up real quick. All right, y'all. So 8.2 is more about polynomials. And 8.2 deals more with graphing polynomial functions. So let's see. The first three questions deal with what's the maximum number of zeros you can have? What's the maximum number of x-intercepts you can have? What's the maximum number of terms you can have? So the maximum number of real zeros. Now we're talking about real zeros because some of these zeros can be imaginary if you're taking square roots of negative numbers on some of these, okay? So we're talking about the maximum number of real zeros. So the maximum number of real zeros is equal to the degree of the polynomial. So if I had a degree of 3, I would have a maximum number of real zeros of 3. Now, it might not be 3, I can have one real zero and two imaginary. But this is saying the maximum number of real zeros is equal to the degree. Well, y'all, we learned that x-intercepts are basically equal to the zeros of a polynomial. So that means the maximum number of x-intercepts is equal to the degree of the polynomial. So once again, it's equal to the degree. Because zeros and x-intercepts, remember, we done a graph where you had to find the x-intercepts and then the solutions or zeros, and they were the same basically. So these two will always be the same. The maximum number of real zeros, the maximum number of x-intercepts is equal to the degree. So what about the turning points? The maximum number of turning points is equal to the degree minus 1. So when we did x squared graphs, they turn one time. So 2 minus 1 gave me one turn. When we do the x cubes, they come up, turn again, and then go up. They turn twice. 3 minus 1 was 2 times, okay? So the maximum number of turning points is equal to the highest exponent minus 1. So y'all, let's look at these first few problems and see what we would do to them. So I'm going to go to our homework and hit number 1. Alrighty, y'all. So for the function, find the maximum number of real zeros, maximum number of x-intercepts, and the maximum number of turning points. So y'all, for number 1, x to the 5th minus x to the 4th plus 8. What is the maximum number of real zeros? And Ben, you got it. It's 5, right? The highest exponent is 5. So that means it had a degree of 5. So you would check that answer. It has a maximum number of how many x-intercepts? So that was 5 also. Remember, those two answers will always be the same, okay? So then you would check that. Has a maximum of how many turning points? And then there you go. 5 minus 1 gave me 4 turning points. So that graph goes up, turns, comes down, turns, up and turns, comes down and turns, and then heads up towards infinity. All right, so good job on that one. So let's see what y'all do on the next one. All right, you got x to the 9th minus 3x to the 5th plus 3x minus 6. So y'all, what's the maximum number of real zeros? All right, Ben, that's 9 again. Good job. 9 is my highest exponent. So what about the maximum number of x-intercepts? So good job. Those two we said were the same, 9 and 9. And then the last one, maximum number of turning points. All right, y'all, good job. That one would be 8. So check answer. So let's see what they did here. Same thing. F of x equals negative 7x minus x to the 5th. All right, y'all. What's the maximum number of real zeros? All right, good job. Out of order, but 5 is still my highest exponent. All right, so what about x-intercepts? All right, once again, that is 5. And y'all, finally, maximum number of turning points. And 5 minus 1 is 4. Good job, y'all. So those three are basically, you're looking at the degree of your polynomial, and it's equal to the degree, equal to the degree, equal to the degree minus 1. All right, y'all, so now we're just going to start looking at graphs. So this one says, hey, use your leading term test and knowledge of y-intercepts to match the function with one of the graphs. Well, A is going uphill, B is going downhill, C is both going up, D is both going down. Which picture would y'all pick for this? 1/3 x squared minus 5. So what I mean is we made a chart while ago with even degrees and positive lead coefficients. So I'm still using that chart. You got an even degree of 2 and you got a positive 1/3 in the front. So remember, when it was even with a positive lead coefficient, both ends went up and it's going to look like C. And that's an x squared graph, so it's got to look like a parabola, either both going up or both going down, okay? If that would have been a negative 1/3, then both sides would have went down on that one. And that's what you got to do on these. Just think about that chart. Like here, this is an x to the 5th minus x to the 4th plus x squared plus 6. Now, do you see down here they're saying all graphs are -5 to 5, -50 to 50? They're telling you if you want to graph it, this is what your window will look like. -5, +5 are your x values. -50 to 50 are your y values. And then it's saying do the scale at 1 for x's and 10 for y. So let me show you how you would do that one on your calculator. So y'all, I'm going to write this down real quick. F of x equals x to the 5th minus x to the 4th plus x squared plus 6. They said -5 to 5, -50 to 50, and x was 1, y was 10. So let me show you how to set a window based on what they're telling you. All right, so I'm going to go to y equals and clear everything off. So they gave me x to the 5th. So x exponent 5, arrow down, minus x exponent 4, arrow down, plus x squared plus 6. Now up here it says window. Right to the right of y equals, it hits window. So hit window and set the x's at -5 to 5. That's your x minimum and max. They said the x scale was 1. On the y minimum, they said -50 to a +50. And they said the y scale should be 10. So once you set your window like they want, you hit graph. And y'all, there's only picture here looks like it's going uphill left to right. So we would go to Math Lab. And the only one that's going uphill left to right would be B. So it had an odd degree, +1 lead coefficient. It's going to go uphill left to right. All right, y'all, same on this one. But look at the difference. A and C are really similar. So you might want to graph this one to see, is it going to be closer to the x-axis like A, or is it going to come down the x-axis like C? All right, y'all, so let's see. They're giving me x to the fourth minus 2x cubed plus 10x squared plus the x minus 15. So it's an even degree of 4 and a positive 1. So it should be both going uphill. So it's got to be A or C. So what we got to figure out um, which one to pick. So notice this says go from negative 5 to 5, negative 30 to 70, and use the x is 1, y is 10. So y'all, I'm going to go to the calculator. I'm going to clear everything off. So I had x, exponent 4, arrow down, minus 2x, exponent 3, arrow down, plus 10x squared, plus the x minus 15. So I'm going to go to the window. They said go from negative 5 to 5, which I got already, and a 1 for the x scale. This one went from negative 30 to a positive 70, and that went by 10 also. All right, y'all, so let's graph it and see what happens. So look, it looks like my graph is coming down the y-axis between that negative 10 and negative 20 there. Because remember, the y's are going by 10. So it's in between the negative 10 and negative 20. So when we go to Math Lab, and I'll make A bigger, A is like on top, but look at C. C looks like I wanted. It's in between the first mark and the second mark in the negative y direction. So if you'll set your windows to match theirs, these graphs aren't that bad. All right, y'all, this one's a negative x cubed. So you got an odd degree, a negative lead coefficient. So y'all, let me ask y'all on this one. Are y'all going with A, B, C, or D? So once again, A, B, C, or D. You got a odd degree. So if you look on your chart, we had odd degrees and a negative lead coefficient. Now on this one, if you was going to graph it, you would go from negative 10 to 10 on the x's, negative 100 to 100 on the y values. And it looks like the y's are going by 10. All right, Ben, you look like you got it. You said D, because remember, it's odd and negative. So odd and negative should go downhill. So if y'all was to graph that one, you would get the graph that looks like D. All right, x to the fifth minus x third. You got an odd degree of 5, and it's a positive 1 in front of those. So A, B, C, or D. And y'all remember, that's an odd degree 5, so it's either got to be A or D. The question is it going uphill or is it going downhill? So Ben, once again, yours looks good, Olivia. Since that's a positive one, it's going to go uphill, left to right. Now, if you graph that one, you would do negative 5 to 5, and then negative 50, positive 50, okay? Oh, look here, they changed the game up. So I got it. X times the x minus 1 times the x plus 2 times the x minus 3. Now I'll tell y'all a trick. How many x's is there? There's an x, there's an x, there's an x, and there's an x. You got 4 x's. So that would be like an x to the fourth, which is an even degree. And then all the x's are positive. So it's even and positive. Good job, Ben. That one would look like B. All right, y'all, but I'm going to graph it. Negative 100 to 100 on the Y. Looks like they're going by 10. Just to show y'all how to do one with the factors being broke up, okay? So clear that. So I had an X and then parentheses, X minus 1, parentheses, X plus 2, parentheses, X minus 3. All right, now remember their window went from, what did I say, negative 5 to 5, and then the Y went from negative 100 to 100. And it looked like they went by tens. All right, y'all, so hit graph, and there you go. Looks like what y'all are saying on that. Let's go to the one that looks like a U, and y'all, it had to be B on that one, okay? And y'all, that's all they're doing on these last few, okay? Um, like this one, you got a negative x, you got x minus 2 squared, so that x happening twice. You got x plus 3 squared, so that x is happening twice. So technically, you got 2, 4, you got 5 x's, and it's negative. So that would be odd and negative. But y'all, look at that. You got 2 going downhill, C and D. So let's graph it on their window. They're going from negative 10 to 10, and then they're going from negative 100 to 100. So y'all, let me write this. I got negative x, x minus 2 squared, x plus 3 squared. All right, y'all, so let's go to our calculator. So I'm going to clear this out. All right, so I had a negative x, and then x minus 2 squared, and then x plus 3 squared. Now my window went from negative 10 to 10, and that's going by ones, and then negative 100 to 100 going by tens. All right, y'all, so let's graph it. All right, so on the left side, it's touching negative 3. On the right side, it's coming up and touching positive 2. So we wanted negative 3 on the left side, positive 2 on the right side, and it's going downhill left to right. So let's see, it's got to be C or D. So let's look. There's C and there's D. On the left side, it's touching at negative 3. Well, y'all C is touching at negative 2. So let's look at D. D is touching at negative 3 over here, and at positive 2, which is what ours had to do. So we would pick D and check our answer. All righty, y'all. So let me write this one down. X minus 3 squared, x plus 1 to the fourth. So let me tell you what's happening here. That exponent 2 means you got 2 x's in the first one. Exponent 4 means you got 4 x's. So 2 and 4 give you 6 x's altogether. And they're positive. So they're going to go uphill both. So it's either A or D. So we're looking for, since that's x minus 3, we want this one to touch at positive 3 and negative 1. So that looks like it's touching at negative 1 and 3 for A. That's what Ben got. And then look, D is touching at negative 3 and positive 1. So that ain't the zeros, that's the factors. So Ben, you're correct. And if y'all were to graph this one, you'd go from negative 10 to 10, negative 20 to 120. If you graph that, you'll get a picture that should look like Ben had for A. Alrighty, y'all, 15x to the third minus 6x squared minus 135x plus 54. Well, that's an odd degree, and it's a positive 15. So, y'all, it's going to go uphill left to right. Question is it going to be B or is it going to be D? So, y'all see that plus 54 at the end? Anytime the number at the end is equal to your y-intercept, the number at the end, that's just a number without the variable. That number is always the y-intercept. So which graph is crossing at 54? Is it B crossing over at 54? Or is it D crossing over at 54? Well, y'all, D is going right through the heart of the origin, right? So D is going right through the origin. So it can't be that one. So the only one it could be would be B. See, it looks like every one of them marks represents about 50. So y'all, let's graph this one. 15x cubed minus 6x squared minus 135x plus 54. They're going from negative 5 to 5, negative 250, 250. So it looks like the x's are going by 1s and the y's are going by 50s when I do my window, okay? All right, y'all, so y equals, clear that out. All right, so I had 15x to the third, arrow down, minus 6x squared minus 135x plus 54. The window went from negative 5 to 5. It went by 1. The y went from negative 250 to 250. And it looks like that was going by 50 each mark. All right, y'all, so once you got that in, you hit graph. And y'all look, it is the one that's above the origin. It looks like it's crossing at about 54 on that, okay? Now, y'all, let me show you this. To set your window back to negative 10 by 10, to set it back to the standard window, you would hit the zoom button and go down to number 6 for standard. That means it's going to set the graph back to a 10 by 10 window when you hit enter. Now, you can't tell what this graph looks like at a 10 by 10 But that's how you set the window back to a normal 10 by 10 window, okay? And if you go back to the window button, look at that. Everything's set at negative 10, 10, 1, negative 10, 10, 1, okay? Um, just remember on this one, use their window of negative 5 to 5 and then negative 250 to 250. So Zoom standard is the quickest way to get it back to the 10 by 10 without you having to go in and actually do negative 10, 10, negative 10, 10, and so forth. All right, y'all. So on that graph, I'm going to definitely pick B and check that answer. So y'all, that's 8-1 and 8-2. 8-1, getting you used to finding zeros, and then what was the leading term, what was the degree and stuff. 8-2 was basically mainly finding the maximum number of zeros and all that, and then graphing a little bit. So y'all, any questions over today?